Let's do problem 23A on page 481 in the textbook. It says, given each of the following sets of values for an ideal gas, calculate the unknown quantity. And we are given these things. We are given that P equals 782 millimeters of mercury, and that V is unknown, that the number of moles N is 0.210 moles, and that the temperature is 27 degrees Celsius. So this looks like the ideal gas law. Ideal gas law is PV equals nRT. A couple of things we have to pay attention to here. Depending on what R we use, and we know R, let's just put that down over here for things we know, is 0.08206, but those units are liter atmospheres over moles and kelvins. So these units all have to be in those units. So for example, this is going to have to be converted. So we're going to need to remember that 1 atmosphere is by definition 760 millimeters of mercury. And that is 1.03 atmospheres. And the other thing is that we are going to have to add 273 to this, which gives us 300 kelvins. Please don't put the degree sign on kelvins. And then over here, we now know everything but V, so let's divide both sides of this by P, which leaves us V equals nRT over P. I'm going to be a little crowded here, but let's put these numbers in. 0.210 moles times R, 0.08206, that's an 8. Liter atmospheres over moles and kelvins. And that's also multiplied by, we need T, which is 300 kelvins. And then all of that is on top of the pressure, which we figure to be 1.03 atmospheres. Let's check out units here. Atmospheres cancel out atmospheres. Kelvins is on top of kelvins. Doesn't much look like it since I got a mess here. And then moles cancel out moles. And what's left is just liters. And that's what we're looking for if it's a volume after all. And that works out to be 5.02 liters. Okay, now a little harder to figure out if that's a reasonable answer because you've got a lot of things going on. There are temperatures that aren't standard, pressures that aren't standard, but it seems like a reasonable number for a problem like this. All right, so that is an ideal gas law problem.